Okay, welcome back to yet another session, and we are going to look at something that is related to what we were looking at last time, using the idea of factors and multiples. So we are going to look at something which we call the lowest common multiple, usually abbreviated as LCM, and we're also going to look at the highest or greatest common factor, which is called the HCF. So today we are going to look at the LCM. We're going to look at the LCM and the HCF. So LCM in full is lowest common multiple, whereas HCF is highest common factor. We can start with LCM. What does it mean when I talk about LCM? LCM is a number which is a factor of two numbers, or in other words, LCM is a number when we have two or more numbers and we compute their multiples. So when we compare the multiples of these two numbers, we look for the common multiples of the both numbers, and then we look for the lowest multiple. That is why we get our term lowest common multiple. In other words, that multiple is common to both or more of those numbers which you're looking for. So LCM is the number. This is the smallest number. Smallest number that is a multiple to two or more numbers. So this is the smallest number that is a multiple to two or more numbers. For example, I can use an example to illustrate this, and we have two methods of looking for the LCM. We can have our example as find the LCM of 8 and 12. That is my first example. Find the LCM of 8 and 12. In other words, look for the multiple that is common to both of them, but it is the least of the multiples. So, there are two methods of solving this. Method number one, I can first list the multiples of 8 and the multiples of 12. From there, I identify the multiple which is common to both 8 and 12. So, in my method one, I start by listing the multiples of both 8 and 12. So I can start with the multiples of 8. So we say to get the multiples, you get this number and multiply it with the natural numbers. So I start with 8 times 1, it gives me 8. 8 times 2 gives me 16. 8 times 3 gives me 24. 8 times 4 gives me 32. 8 times 5 gives me 40. 8 times 6 gives me 48, and so on and so on and so on. Let me look for the multiples of 12. So for the multiples of 12, you get 12 and first multiply it by 1. So 12 times 1 is going to give me 12. 12 times 2 is going to give me 24. 12 times 3 will give me 36. 12 times 4 gives me 48. Now already when you compare these two multiples, you can see that there are some numbers which are common in both instances. Then 12 times 5 gives me 60, and so on and so on. So after identifying the multiples of 8 and the multiples of 12, the next step is to identify the common multiples. In other words, the multiples which are in this set and they are also in this set. The common multiples. So the common multiples in this case we have, when you look at this set and this set, I have 24 here and I also have 24 here. So I have 24. When I proceed, 32 is not here, 40 is not here, 48 is here, it is also here, 48. So these are my common multiples. Now, out of these common multiples, which one of them is the smallest? That is what we mean by the LCM, in other words, the lowest common multiple. So between 24 and 48, which is smaller than the other? And the answer is 24 is smaller than 48. So finally my LCM is going to be 24. And that is method 1. We say we first list the multiples, look for the common multiples, and then identify the smallest multiple. Now method 2 is where we're going to use division or prime factorization. So here we have method 2. So I can write my 8 and 12 in tabular form. I have 8, I have 12. So I'm going to divide these two numbers by prime factors. In other words, if there is any prime factor which divides either 8 or 12, I divide through by that prime factor until it can no longer divide. So my first prime factor in this case is going to be 2. Does 2 divide 8? The answer is yes. So since it divides 8, even if it does not divide 12, I can still use it. Because the prime factor you're using in that case must divide at least one of them. So I have my 2. 8 divided by 2 gives me 4. 12 divided by 2 gives me 6. I proceed. Between 4 and 6, is there any number that is still divisible by 2? The answer is yes, because 4 is divisible by 2. And we say for you to use any prime factor, that prime factor must divide at least one of the numbers in this column. So when I divide 2 here, when I put my 2 here, I'm going to have 4 divided by 2, and my answer is going to be 2. Then 6 divided by 2, my answer is going to be 3. I still proceed until in these two columns I have 1, 1 at the very end. So between 2 and 3, is there any number which is still divisible by 2? The answer is yes, because 2 is divisible by 2. So I still use 2. So 2 divided by 2 gives me 1. 3 divided by 2 gives me 1 remainder 1. In other words, 2 does not divide 3. And when the number here, when the prime factor here does not divide the number here, you leave this number the way it is. So if I had 3 here, I'm going to leave the 3 as 3. Since the 2 did not divide the 3. Then after that, since I have the 1 here, I proceed to the next prime factor, which is 3. Between 1 and 3, is there any number that is divisible by 3? The answer is yes, because 3 divided by 3 gives me 1. So I can use a 3 here, and then I'm going to have, since 1 does not divide 3, I leave it the way it is. Then 3 divided by 3, my answer is going to be 1. Remember we said you stop when you have 1, 1 in these two columns. So after that, I'm going to get these numbers which I have on this side and multiply them. So here I'm going to have 2 times 2 times 2 times 3. So I can pair this. 2 times 2 gives me 4, whereas 2 times 3 gives me 6. 4 times 6 is going to give me 24. So we observe that the answer here is the same as the answer in this case. So whether method 1 is easier for you or method 2 is easier for you, it is upon you to choose. The easier method for you is the one you should always use if rather than a question is passed on to you.